Welcome grade 4 students. Good morning to you all. How are you this morning? Today we are going to begin chapter 7 with lessons related to addition and subtraction of fractions. Today's lessons are: add and subtract parts of a whole, write fractions as sums, subtract fractions using models, and add and subtract fractions. So are you ready for the new lessons with your teachers? Let's get started. What are the objectives of today's lessons? To understand that in order to add or subtract fractions, we must refer to parts of the same whole. Decompose a fraction by writing it as a sum of fractions with the same denominator. Use models to represent and find differences involving fractions. Solve word problems involving addition and subtraction of fractions. Fractions represent equal parts of a whole. Fractions of a whole. When we divide the whole into equal parts, each part is a fraction of a whole. Let's use a model to understand this. This is a slice of a watermelon. It's one whole. This whole can be split into some more parts. I can split this as 2 halves. So I can write this fraction as half plus half. This 2 halves can be split further as 4 quarters, and it can be written as 1/4 plus 1/4 plus 1/4 plus 1/4. If you notice, all these parts still belong to the same whole. Let's read this problem. I have some pie pieces left over on my plates. I want to combine the pieces so that it's all on one plate. I want all those pieces on one plate. How much pie will be on the plate now? You must be wondering why I always use pies and pizzas and cakes. That's because they can relate to fractions very well, as we can count them easily, the total number of parts, and we can split them up accordingly. So here are my 2 plates. In the first plate, I have 3 pieces of pie left. In the second plate, I have just 1 piece of pie left. Now I want this 1 pie to be on this plate so that I can eat it later together. Let's have a model for this so you will understand it better. This is a model that represents a number of parts of pie I had on this plate. And here, this plate is a similar plate where just 1 piece of pie is left. We would like to show you how you're going to count those number of pieces of pie together. So, let me shade them now. I'll use my pen and I'll shade 1, 2, and 3 parts, just as in this plate. So there are 3 pieces of pie, the same as here. Now, what do you think your next model would look like when you add these number of pieces? Yes, you're right. When you add them up, you're going to get 1, 2, 3, and 4 pieces in all, which I will shade it this way: 2, 3, and 4. Am I right? Now, how about writing them as fractions? I would say this is 3/6 plus 1/6 would give me 4/6. You're right. You got it now. Now suppose I want to eat 2 pieces of these. So, how would it look like then? These are the same number of pieces that's shown over here, 4/6. Now from the 4/6 I'm going to eat 2 pieces. So I would cross these 2 pieces. Now, how much pie will be left on my plate after eating those 2? It's just 2 pieces, right? So your final fraction would be 2/6. Yes, after I eat the pieces, I just have 2 pieces of pie left on my plate. So now my fraction is 2/6, as you can see here. Let's use a model to write an equation. You can see the number of equal parts are 1, 2, 3, 4 and 5. Similarly, you have 5 parts in here and 5 parts in the final fraction. When you add them up, here, how would you represent this fraction? 1/5, you're right. Plus, what about this? 2/5, you're right again. Equals, how about the final one? You add the 1 with the 2. You have now 3 parts. So the fraction would be 3/5. As you can see, we've added the shaded parts finally to get an equation. So this part over here is known as an equation according to the given model. Let's have another example. What about this? What do you see in here? You can see a 1 whole has been split into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. And then, how many have been shaded? 1, 2, 3, 4, 5. That means your fraction is 5/8. And then, how many parts have been crossed out or removed? You know, when we cross out or remove, it means it's subtraction. You need to subtract, right? So, your initial fraction is 1, 2, 3, 4, 5. 5/8 minus 3/8. So, how many would be left now? You now have 2/8, as you can see in the model. Now we are going to represent this in form of an equation. You would write this as 5/8 minus 3/8, and you would get 2/8. Is it correct? Yes. So this is an equation for this model where you remove or minus or subtract the number of parts. And this is an equation where you add the number of parts in a fraction. Let's try this problem. A common house spider has 8 eyes. If a spider is looking at you with its 2 front eyes and 3 of its other eyes, what fraction of its eyes are looking at you? Oh my God, how many eyes does the spider have then? You know what's a common house spider? Have you seen it? Yes, for sure. This is a common house spider, and I can't see it with his eyes here. So let me show you another picture with the 8 eyes. Wow, scary, creepy. Let's count the number of eyes. 1, 2, 3, 4, 5, 6, 7, 8. 8 eyes of a common house spider. Now, it says it has 8 eyes. I agree. What about with 2 front eyes? Okay, these are the 2 front eyes. Let me show you. Let's say, for example, he's looking at you with his front two eyes. Let me use another color. Maybe he's looking at you with these two front eyes and maybe three of those other eyes behind. Now, what fraction of its eyes are looking at you? You can count them easily because you know that the total number of eyes he has is 8, and you have two front eyes and three of his other eyes looking at you. So how would you write this in form of a fraction? 2/8 plus 3/8 is equal to 5/8. So here is your answer. 5/8 of the spider's eyes are looking at you. Be careful, he's watching you. Let's solve a problem. See if you can solve it on your own. Andrea is supposed to practice piano for 4/6 of an hour every day. Today she practiced only for 2/6 of an hour. What fraction of an hour does she need to practice? Now, after you read this information, make sure that you underline the given information and then you underline what you need to find. And how would you do that? Would you add or subtract? I want you to solve this problem and send it to me on Class Dojo. Remember, we can only join or separate parts that refer to the same size whole. Let's read the problem, look at the given models and answer the question. Karen has 1/4 of a round cake and 1/4 of a square cake. Let's see how the cake looks like. This is 1/4 of a round cake and this is 1/4 piece of a square cake. Let's see the question that follows this model. Does the sum 1/4 plus 1/4 equals 2/4 make sense in this situation? Do you agree that when you add 1/4 of this round cake to 1/4 of this square cake, it's equal to 2/4 in all? Do you agree? No? Why not? Yes, because you know this sentence that tells you we can only join or separate parts that refer to the same size whole. You can see that these wholes are not of the same size. 1/4 of the round cake and 1/4 of the square cake are not parts of the same size whole. Do you agree with me? Also, if you notice, 2/4 of a cake means she has 2 pieces of a cake divided into 4 equal size pieces. But these 4 pieces are not of the same size. So that doesn't sound true. So I disagree, and I'm sure you will disagree too, that 1/4 plus 1/4 equals 2/4 in this case is not correct. Unit fraction. What do you mean by unit fraction? It tells the part of the whole that one piece represents. Also, a unit fraction always has 1 as the numerator. Remember this, okay? A unit fraction always has 1 as the numerator. Let's write a fraction as a sum of unit fractions. Let us see how we can write a unit fraction for 5/6. We can write this as 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. That's it. You have written it 5 times. So that gives you, if you add it up, 5/6. Now each unit fraction here is called an addend. What is an addend? They are the terms that are added together to get you the fraction. But you need to add them. That's why they are called as addends. How many addends do you see here? 1, 2, 3, 4 and 5. So these are all called addends. Now in this case you see it's just the model of the same. You have 1, 2, 3, 4 and 5 sixths. So this is how it's represented, and this you know is called as an equation. Correct? You learned it a while ago. And these are addends. And how many addends do you see in the above equations? Yes, you know it now. It's 5 addends in all. Write the fraction as sum of unit fractions. We saw it a while ago. How to write a fraction as the sum of unit fractions. 4/12 can be written as 1/12 plus 1/12 plus 1/12 plus 1/12. And how many addends do you see in this? Yes, you see 4 addends. Now let's try to decompose a fraction. You will be given a fraction and you need to decompose. You need to split them up into different addends, not necessary unit fractions. Okay, so let's do that using models. Decomposing a fraction in different ways. The given fraction is 7/9. How will I decompose this? Using different addends. You can do it using fraction strips or models. So when you see the denominator is 9, that means you have 9 parts in the model, out of which you need to split the numerator, that's this number 7. So let's see how it's done. This is the given model. Now, if I need to split the 7, I could split this up as 2, then 3 and 2. So, in this case, what I would do is, I would use a color and shade these parts into different parts which are given here, so that you would know each part represents which fraction. So I would shade first the first part, and I would shade the second part with the color blue. So I would have 2/9 as my first addend. Now I would like to change the color. I would use a green now. I would like to shade 3 parts of this model, so I could get my next addend to be 3/9. Then I still need to make it 7. It's just 1, 2, 3, 4 and 5 now. So I would need 2 more parts. I will use another color. I'll choose a red this time. So I could shade 1 and 2. So that gives me in all 7 parts. Now here my fraction would be 2/9. Correct. How can we write this as an equation? 7/9 equals 2/9 plus 3/9 plus 2/9. You can see these are all different addends here, and we've decomposed them into different fractions to give you the actual fractions. Yes. Now let's see if there is any other way to decompose a fraction. Why not? Let's try. What about this? I would like to decompose in a way with 4 plus 2 plus 1. That could give me 7 also, right? So let me take This time 4 parts. So 1, 2, 3 and 4 parts. Okay, so I have my first addend in here. That's 4 nines. Now I'll choose another color. I'll choose a brown this time. In this case now I want to shade say 2 parts, and then my next addend would be 2 ninth. Now I still have one more part. Let me take another color. Let me choose purple this time, and I shade this one part. So here in this case my addend will be 1 ninth. Now let's see how we can write the equation for the same. 7 ninth equals 4 ninth plus 2 ninth plus 1 ninth. There you are. Isn't it easy? You can choose any addend, but please remember the sum of the numerator should be equal to the numerator of the given fraction. Now let's see another example. Okay, here you are. How would I do this now? How about 5 this time? Okay, 5 and then 1 and then 1. 5 plus 1 gives me 6 plus 1 gives me 7. So this time I would like to choose 5 parts. I'll shade them all. 1, 2, 3, 4 and 5. And then let me choose 1. So I'll choose a brown for this one. And now let me choose green. This time a light green. Okay, so here I am. So I get 7 as well. So as you can see, your first addend here would be all these colors on purple would be 5 ninths, right? How about this? 1 ninth. And how about this also? 1 9. So how would you write your fraction now? Your equation would be 7 ninth equals 5 ninth plus 1 ninth, correct? And then again 1 9. So as you can see, you've decomposed your fraction in so many ways, and you can try that at home. And if possible, you can also send it to me in Class Dojo so I can see your work. Write the fraction as a sum of fractions in 3 different ways. We have just done it. 8/10 equals, how could you write this? There are 3 different ways. You can even write more if you can. Okay, let's have them. Let's see. If yours is the same as mine, 6/10 plus 2/10. Yes, this is one way of decomposing. 8/10. What could be the other way? 5/10 plus 2/10 plus 1/10. I'm sorry, this should have been 10. This is my mistake. Excuse me for my mistake. Okay, the other way is 4/10 plus 2/10 plus 2/10. That's it, right? You can even have 4 addends, 5 addends, as much as you like, but try to decompose it as many ways as you can. I would like you to do this on your own. Write the fraction as a sum of fractions in 3 different ways. I hope and I know for sure you will be able to do this and send me a picture after you solved it on Class Dojo. Let's see this activity. You need the materials as color pencils. I'm sure you have them. This is a sail of this boat. Now, they have given you a question. Look at the 8 triangles in the sail. So 1, 2, 3, 4, 5, 6, 7, 8. You have 8 triangles in this sail. Use the guide below to color the triangles and answer the question. So you have a guide that I'll give you here now. 2/8 should be blue in color. 2/8 of these triangles. When I say 2/8, you know it very well how many parts you need to color blue. Okay? Then you have 3/8 should be red in color. 2/8 again orange in color. And 1/8 yellow in a color. Okay? So once you color them, you will answer the given questions that follows here. Okay? Write an equation that shows the fraction of triangles that are red and blue. You're going to write an equation. You have seen we've solved many equations. We've written many equations. So in this case, you're going to write an equation that shows the fraction of triangles that are red and blue only. Focus on red and blue. You're going to solve it. Write the equation. Next question says, which color is used the least in the sale? Among all these colors, which color is used the least in the sale? You're going to write the name of this color. Once you answer these questions, please send it to me in Class Dojo. I would like to see this activity. It should look really colorful, okay? And I'm sure you all can do it.